Alright, just going to have a look at another calc-free exam style question for methods unit 1 and 2, so year 11 methods. This is a question from a past exam, and this is the sort of type of question, I guess, that is expected you can do without a calculator in your exam in terms of differentiation, before we get into too much sort of context, I guess, in terms of tangents and things like that. So we need to determine the derivative. Now remember, f prime of x, y prime, dy by dx, they all mean the same thing. So for this particular question, it's asking us to find the derivative of f of x. So this is my derivative, the function I have to derive rather, just here. So the first thing I'm going to do is make this a little bit easy to work with. This is x squared on 4. So I'm going to change this to 1 on 4x squared. Alright, just to make that a bit simpler. Now, remember this one here, this is like x to the 1, and it is the denominator rather, in my fraction. So I can actually modify this to make it look like negative 4x to the negative 1. And that makes it a little bit easier to set up and to work with. So I can now start to calculate my f prime of x. Now remember, for these, when we're doing the derivative, power comes out the front, reduce the power by 1. So this is going to look like 2 times by a quarter x to the 2 take 1. Again, I'm putting this step in, but when we have a bit more practice at it, we don't need to do this. We'll be able to jump straight to our answer almost. Now subtract. Now this is a negative 1 here. Now when I bring this out the front, that negative stays with it, but just for now I'm going to keep that take away sign. I'm just going to put all this in brackets, so it becomes negative 1 times by 4 x to the negative 1 take 1. Alright, power comes out the front, reduce the power by 1. So we can now look at simplifying that down a little bit. Now 2 times a quarter, remember this is like 2 on 1, so 2 times 1 is just 2, 1 times 4 is just 4, and we will be able to simplify that a little bit more in a second. 2 subtract 1 is just 1, so I can just leave that as x. I'll leave it as to the 1 here, just so we can see how that changes from there to there. And then I'm going to still leave my subtract in there for now. Open up my bracket. Negative 1 times 4 is negative 4 x. Negative 1 take away 1 becomes negative 2. So I can now simplify this even further. 2 over 4 is the same as 1/2 x. Again, I don't have to put to the power of 1 there. Negative and a negative becomes a positive. 4x to the negative 2. 4x to the negative 2. Now, our answers, we always want positive indices. Now I've got a negative indice here. I don't like that. So I'm actually going to change this again. Now remember, if this is negative 2, I can flip it, make it the denominator in a fraction, and then change my answer to 1/2 of x plus 4 on x squared, and that is my answer. Or again, you can change this bit here into x on 2 plus 4 on x squared, just like that. Next question I'm going to have a look at is a little bit trickier one. I thought it was quite a good question in terms of it is just a little bit different to what is, I guess, normally asked for. Now what this question is saying is we're asked to determine the derivative of this function y equals 2 on 3 a x cubed plus a squared, where a is a constant. Alright, so that is a constant value, so it behaves like a number. Alright, now these sort of questions are chucked into, I guess, trick you a little bit, but all we have to remember is that a is just a number. Alright, it is not the variable. Okay, if we were asked to do the derivative of this function, so if a was not a constant, this would be dy over dA, but we have dy over dx, so we're doing the derivative with respect to x. A is just a number, constant value. So I guess what I'm going to do first is I can jump straight into my gradient function. Now we have 2/3 ax cubed. Again, when we've got two terms, we just look at them separately. I'm going to bring the power out the front, reduce the power by 1. So this is going to become 3 times 2/3 ax to the 3 take 1. Now this a squared, this is like a number. This could be 2 squared, 4 squared, 100 squared. Doesn't matter, it's still just a number. And when we do the derivative of just a number, it just becomes 0. So I can jump straight to that step there. So from a question that looked quite tricky, we can make it quite simple just in that step there. Now I'm just going to simplify this down. Remember, this is like 3/1. 3 times 2 is 6. 1 times 3 is 3. Ax 3 take 1 is 2. I don't need to include my plus 0 here. 6 on 3, and my final answer is going to be 2 ax squared. And that's my final answer just there. The next question that we're going to have a quick look at is one again that is a little bit trickier in how it is given to us. If I can find it. There we go. So this question here, right, again we're asked to determine the gradient of this gradient function, the rate of change, the derivative, whatever you want to call it. Alright, remember dy by dx, f prime of x, y prime, all that sort of stuff just means the derivative, the gradient function. So with my equation here, I can do a couple of things to it to start with because it's not completely simplified. We have 6x take 3x cubed divided by 2x. Now what I can do straight away is I can cancel that x out there, alright, and I can then jump straight to that, alright, because I've got an x on the bottom, so this x is going to cancel the x from this term, and it's going to cancel one of the x's from this term. So what I end up actually getting here is 6 take 3x squared on 2. Now 6 divided by 2 is just 3, and then I'm subtracting 3 on 2 x squared. So this is now my function that I am doing the derivative of, and it's a bit nicer than what we had to start with. Now remember, this is just a constant, just a number, so the derivative of that is simply 0. Now the next bit I'm going to look at, okay, this is negative 3 on 2 x squared. Okay, my 2 comes out the front, so we get negative 2 times 3 on 2 x to the 2 take 1, just like that. Now 2 times 3 is 6, alright, so this right here is going to be 6. 6 divided by 2 is 3, so this is going to become negative 3, and then 2 take 1 becomes just x. Just like that. Now the last question I'm going to have a look at, this is I guess the sort of question that gives us a little bit of context. So this is I guess more what we actually use our gradient function for. It is what we I guess the reason behind why we do it. So just make sure I can fit all that in. So we are asked to determine the equation of the tangent to the curve y equals x subtract x cubed subtract 2 plus 2x squared at the point x equals 1. Now I'm asked to determine the equation of the tangent. Remember, our form of our tangent, alright, any tangent is a linear line. So we have y equals mx plus c. So I need to determine, using what I've been given here and here, to work out m, and work out C, work out the gradient of that line and work out the y-intercept. So the first thing I need to do, I need to find the gradient. To find the gradient, I need to find the gradient function of this equation, of this curve, and then plug in this point of x equals 1 into my gradient function, because that will tell me the gradient at the point 1 and hence the gradient of the tangent. So we jump straight into dy by dx is going to be equal to, now the derivative of x is just 1. The derivative of x cubed, remember the power comes out the front, reduce the power by 1, 3 take away 1 is 2. 2, negative 2 rather, this is just a constant, so that becomes 0, so we don't have to write anything. 2x squared, power comes out the front, become 2 times 2, so I'm going to get plus 4x. Now that is my gradient function. Now what I want to do, I want to do the gradient at x equals 1. So now dy by dx, I'm just going to substitute in 1 for x. So I'm going to get 1 subtract 3 lots of 1 squared plus 4 lots of 1. And that is then going to become 1 take away 3 plus 4, and I end up getting 2. What does that mean? Well, that means that therefore my m, my gradient of my line here, is equal to 2. Fantastic. So now I can sort of start to make this into a bit more of a function. We have y equals 2x plus c. So now I just need to find the c. Now normally how we would solve that for a linear sort of line, we would have a coordinate, or we would substitute in our x value and our y value. Now I've only been given an x value. I need to find the y value at this point. How am I going to do that? Substitute in 1 into my original equation, because that will tell me, well, what does y equal when x equals 1 of my original. Now I'm going to do this in a different color, so hopefully it's a little bit clearer. So I want to know when x equals 1, what does y equal? So I'm going to have 1 subtract 1 cubed subtract 2 plus 2 lots of 1 squared. Alright, so y is going to equal 1 take away 1, which is 0, take away 2 plus 2, which is actually going to give me 0. So this is now my coordinate that I can use to put into this one here, because I now know, and again I'm going to use a different color, because I now know that y equals 0 at that point. I know my gradient is 2. I know that when x equals 1, then we're going to have some constant, some c value on the end, in my y-intercept. So if 0 equals 2 plus c, what does c need to be to make this equation true? C needs to equal negative 2 in order to make that correct. I now have all the parts for my final equation of, therefore y equals 2x take 2. That is the equation to the tangent, of the tangent rather, to the curve y equals x take x cubed take 2 plus 2x squared.